Okay, so the first couple here we're asked to reduce. Now we can either look for that greatest common factor, like we had mentioned before, or we can just go ahead and start looking for things that go into both of them and divide them out. Um, for the first one here, both 28 and 42 can be divided by 2. Let's go ahead and do that first since they're both even. 28 divided by 2 is 14, and 42 divided by 2 is 21. And now that they're smaller, it might be a little easier to see that both of those divided by 7. 14 divided by 7 is 2, and 21 divided by 7 is 3, giving us 2/3. Number 2, when we look at it, we see that both of those end in either a 0 or 5, so we know both of them can be divided by 5. So let's do that first and see where we end up. 30 divided by 5 is 6. 75 divided by 5 is 15. Now at this point, again, with the smaller numbers, it might be a little easier to see that both of those can be divided by 3. 6 divided by 3 is 2. 15 divided by 3 is 5, giving us 2/5. Any questions on those first two? Okay, so number 3, convert to mixed numbers. To do this, the easiest way to do it is to do a division with a remainder. Okay, the easiest way to do it is to the calculator to automatically do so. There's a couple of you that have some background noise. If I can get you guys to mute your microphones, and if you need to talk, you can unmute. Otherwise, I have to mute you from my end, and then I can't hear you if you need to talk. Thanks. I think we got her. So now 5 going into 47. 5 goes into 47 9 times. 9 times 5 is 45, and there's 2 left over. So that's saying that there's 9 whole objects and 2 pieces, so 2/5 left over. For number 4, 35/4, we'll do 35 divided by 4. 4 goes into 35 8 times. 8 times 4 is 32. We subtract, there's 3 left over. So that's 8 whole objects and 3 pieces, or 3/4 left over. Going the other direction. Any questions on converting those to mixed numbers? Going the other direction now, from mixed numbers back to improper fractions, we have 3 and 2/5. We need to break those 3 whole objects into pieces. It's 3 times 5, that's 15 pieces. Adding that to the 2 gives us 17/5. 4 and 7/8. Well, again, we take the 4 whole objects, we break it into pieces, we multiply by the denominator to get 32 pieces. Add that to the 7 that we already had. That's 39/8. Any questions on those couple?
Yeah.
Go ahead.
Number 5, 3 went into 3 times 5 equals 15.
Yep. And then 15 plus the 2 gives us the 17.
Yeah, and you're bringing the 15 up. I might be overthinking it, but it feels like we're missing a 5. No,
This
never mind. It's in my head.
Okay, no problem.
This 5 is just a placeholder in this case. I got you.
Yep, yeah, the 5 stays there. The name doesn't change.
Yeah.
Yep. It's actually a very similar calculation if we have like 3 feet and 5 inches. Most of the time it's not taught this way, but really that's a mixed number. We can think of that as being 3 feet and 5/12 of a foot, because an inch is a 1/12 of a foot. And so then to convert that all into inches, it's 3 times 12 is 36. Add that 36 to the 5 is 41/12 of a foot, or just 41 inches. So it's a very similar calculation to doing those conversions. All right, any other questions?
No, Mr. Harper.
to call me out if you catch that. I do that quite a bit. So, and I'll warn you, once I've done it once for the day, I tend to keep doing it for some reason. So it might be one of those days. Okay, any other questions? Okay, so let's go ahead and I'm laughing because Gabe's dog is up in the middle of the screen looking around. I'm a dog lover, so it kind of amuses me. Sorry. So anyway, we're going to look closer at fractions today and doing a little bit more in-depth work with them. I'm looking at operations with fractions. Now, we've talked about renaming fractions. And if we have something like 3/5 plus 1/4, like we did on the first day, before we can add those, we have to rename them. We have to give them the same name so that we can add them. So the biggest question we have to talk about is, what name should we change them to? Or I suppose if this were an English class, they'd say, to what name should we change them? But this is a math class.
20.
20 is what it's going to be, yes. That is referred to as the common denominator. And there are actually several ways of finding the common denominator. For most people, once they've worked with fractions for a while, they get to where they can just look at them and think for a bit and figure out that common denominator. But one method is to simply multiply. If I multiply my two denominators, in this case 5 and 4, 5 times 4 gives me 20. That will always give us a common denominator. It might not always give us what's called the least common denominator. In this case, it actually is the least common denominator. Other methods that have been used for doing least common denominator might be to make lists. In other words, you start with the 5 and with the 4, and you count up, or you do multiples. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 20, 25, 30, and on up. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 16, 20. There we have found smallest one. Now there are other strategies with prime factoring and stuff like that. Excuse me. With prime factoring that allow us to find that, but they get pretty complex. And for the most part, if we get really stumped, we can make the list. But for the most part, we can work with a fraction and find its common denominators. Now that I know my common denominator here is going to be 20, I'm going to rewrite this. I am used to adding numbers vertically, so I'm going to rewrite this vertically. Also a little bit easier to change it to common denominators in that format. Our common denominator is going to be 20. So we have to rename both of these fractions to be 20ths. So what did I multiply the 5 by to make it a 20? That was a 4. So I have to multiply the 3 by a 4 as well. 3 times 4 is 12. 12 20ths is equivalent to 3/5. The 4ths into 20ths, well, 4 had to be multiplied by 5. We multiply 1 by 5 to get 5. Again, 5 20ths is equivalent to 1/4. Well, now that we have the same name over here, we can go ahead and add. We're going to combine the counts. 12 plus 5 is 17. And keep the same name, 20ths. Now, I'm not going to do a lot of examples of simple fractions. We're going to jump up to the next level, which is mixed numbers. If I have something, and I'm going to write this out vertically right away. Like 4 and 1/4 plus 2 and 2/3. Well, I still need to find a common denominator. Now I'm going to rewrite the whole number. And to find the common denominator between 4 and 3, actually comes out to be 12. Turn a 4 into 12 had to be multiplied by 3. So 1 times 3 makes 3 twelfths. 4 and 3 twelfths is equivalent to 4 and 1/4. Turn the 3 into 12, we multiply by 4. So we multiply the 2 by 4 as well to get 8 twelfths. Now we have to add here. Again, just like whole numbers, we start at the right and work our way back to the left. You might notice the fraction is sitting at the end almost like it's just the last digit of the number. And that's exactly what it is. The fraction is just the last digit at the end of the number. So we start with the 3 twelfths plus the 8 twelfths. Combine the counts. 3 plus 8 is 11. And we keep that same name of twelfths. And then, did it again. That should be just a 2 there, not a 4. 4 plus 2 is 6. So 6 and 11 twelfths. Let's do another example, maybe a little bit more complex. 7 and 3/4 plus 5 and 1/6. So again, I am going to rewrite the whole number. Now, some textbooks teach that you just rewrite the fraction. I always rewrite the whole number because I found that if you just rewrite the fraction, sometimes people forget to go back and use the whole number too. For 3/4 and 1/6, their common denominator, well, actually, once again, comes out to be 12 as our least common denominator. 4 times 3 makes 12, so we do 3 times 3 is 9. 7 and 3/4 is equivalent to 7 and 9 twelfths. 6 times 2 makes 12, so 1 times 2 is 2. We have common denominators. Now again, we start at the right and we work our way back to the left. 9 twelfths plus 2 twelfths is 11 twelfths. 7 plus 5 is 12, so 12 and 11 twelfths. Now, if you did not see that there's a least common denominator of 12 there, you could have just multiplied the denominators. 4 times 6 would be 24. That would work just fine, although it's going to be a little bit more work. 4 times 24. To make 4 into 24 would be times 6. So 3 times 6 would be 18 24s. 6 has to multiply by 4 to get 24, so 1 times 4 would be 4. When we add 18 and 4 make 22. Well, 22 24ths, we see we can reduce that by 2 to get 11 twelfths. And 7 plus 5 is 12. So if you use a larger denominator, you'll still get the right answer. You just may have to do an extra step at the end to reduce the fraction portion of your answer. Let's look at subtraction. Subtraction, we've said before, follows the same rules as addition. That's true. We have to have the same name. Once we have the same name, we combine the counts and we keep that same name. So, let's look at something like 7/8 minus 1/6. Our common denominator there is going to be 24. 8 times 3 makes 24. We do 7 times 3 is 21. 21 24ths. 6 times 4 makes 24. So 1 times 4 is 4. 4 24ths. And now we're subtracting and not adding. So we still combine the counts, but it's 21 minus 4 makes 17. And we keep the same name of 24. Now again, I'm not going to keep it that simple. I'm going to jump up to mixed numbers. Do something like 8 and 2/3 minus 3 and 1/5. Now again, we need to find that common denominator. In this case, it'll be 15. 3 has to be multiplied by 5 to make 15, so 2 times 5 is 10. 5 times 3 to make 15, so 1 times 3 is 3. And again, like always, we start on the right, work our way back to the left. That fraction is just the last digit at the end of the number, so we start with that. 10/15 minus 3/15. 10 minus 3 is 7. And we keep the 15. Then we do the 8 minus 3 is 5. Now, so far, all of the examples I've done with addition and subtraction of mixed numbers have been pretty simple examples. It doesn't stay that simple. We run into things like this. And we might have 5 2/3 plus 4 7/8. So let's go ahead and find our common denominator. Between 3 and 8, it's going to be 24. Turn a 3 into a 24, we multiply by 8. So 2 times 8 is 16. So 5 2/3 is equivalent to 5 16/24. To turn an 8 into 24, we multiply by 3. So 7 times 3 is 21. And now we go ahead and add, once again, starting at the right, working back to the left. 16 24ths plus 21 24ths. Combine the counts, 16 and 21 make 37 24ths. Now here's where the difficulty comes in. That's bigger than 1. It's an improper fraction. We can reduce that. 24 goes into 37 once with 13 left over. 1 13 24ths. So just like with whole numbers, we keep part of it. We keep the 13 24ths, and we carry part of it. We carry the 1 over into the whole numbers. Now 1 5 is 6 plus 4 is 10. They get 10 13 24ths. For subtraction, we have similar issues that come up. We might have 7 3/4 minus 2 5/6. We have a common denominator between 4 and 6. 12 will work. We could have also used 24, but 12 is a little bit smaller. To turn the 4 into a 12, it had to be multiplied by 3. So we do 3 times 3 is 9 twelfths. Turn the 6 into a 12, multiplied by 2. So we do 5 times 2 is 10 twelfths. And here's where we run into the issue. We go to subtract, again, starting on the right, working our way back to the left. 9 twelfths minus 10 twelfths can't be done. So just like with whole numbers, we have to borrow from the next digit. We borrow from that 7 and it becomes a 6. We do not just put a 1 there because what we've borrowed is one whole object. To know how many pieces that is, we have to look at the denominator. That denominator tells us that's 12 pieces. So we've borrowed 12 pieces. So we add that 12 to the numerator. 9 plus 12 is 21. So that is now 21 twelfths. Now 21 twelfths minus 10 twelfths. 21 minus 10 is 11. And we keep the same name of 12. 6 minus 2 is 4. Let's do another subtraction with the borrowings because that is a little bit complicated. Oh, let's do this. 72 2/3 minus 39 7/8. So even though there's more digits in the whole number, it's still the exact same process. We have to find our common denominator. Between thirds and eighths, that ends up being 24. 2/3, well, 3 times 8 is 24, so 2 times 8 is 16. I'm going to start flying through some of the conversion parts because at this point I'm hoping you've caught on. If you still struggle with it a little bit, let me know and I'll slow down and go over it in more detail. 8 into 24, you have to multiply by 3, so 7 times 3 is 21. Now we go to subtract here. 16 24ths minus 21 24ths can't be done. We have to borrow from the 2. That's going to become a 1. Well, that 1 that we borrowed has 24 pieces in it. So we add 24 to the 16. That's 40 24ths. Now we subtract 40 24ths minus 21 24ths is 19 24ths. Move over to the next digit. 1 minus 9 can't be done, so we borrow from the 7. That's a 6. This is now an 11. 11 minus 9 is 2. 6 minus 3 is 3. 32 and 19 24ths. Any questions there? Okay. Multiplication. We might look at 3/5. Actually, let's do this. 3/4 times 2/5. When we multiply, we do not need the same name. That means we don't have to worry about finding a common denominator or changing the names before we multiply. We are going to combine the counts, and that means multiplying the numerators. 3 times 2 is 6. And then also combine the names, which is just multiplying the denominators. 4 times 5 is 20. Now you might have noticed those can both divide by 2, so we'll reduce that. 6 divided by 2 is 3, and 20 divided by 2 is 10. 3/10 is our answer. Now, some of you might be looking at that wondering, well, why didn't he cross-cancel, or sometimes called cross-multiplying? Some of you right now might be wondering, well, what is cross-canceling? Well, when we multiply this, we know that it's just going to be 3 times 2 on top and 4 times 5 on bottom. And you might notice that both the 4 and the 2 can be divided by 2. So we can divide that out before we multiply. 4 divided by 2 is 2, so I replace that with a 2. 2 divided by 2 is 1, so I replace that with the 1. Now when we multiply, it's 3 times 1 is 3. 2 times 5 is 10. Basically, all we've done is we reduced before we did the multiplication. Now, in a problem like this, it's about the same amount of work either way. We could reduce later or we can reduce first. But we run into problems like this. 24 25ths times 35 36, where we could multiply this out. 24 times 35 is 840. And 25 times 36 is 900. And then we could go through the trouble of reducing that. They end in zeros, so both divide by 10. 84 over 90. They're both still even, so they both divide by 2. That's 42 over 45. If you add the digits, you find that both of those still divide by 3. 42 divided by 3 is 14, and 45 divided by 3 is 15. 14/15 is what that reduces to. Which, again, that's not impossible to do, but you're working with some pretty large numbers when you multiply that out. So in this one, to me at least, it's easier if we do this cross-canceling first. You might see that both 24 and 36 divide by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. You may have only seen that they divide by 6. You divide by 6, you get 4 and 6. You see that they can divide by 2 again. Just divide again, just like reducing. 25 and 35 both divide by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. And now we multiply. 2 times 7 is 14. 5 times 3 is 15. So to me, it saves a lot of work if you can do that cross-canceling to reduce before you multiply them out. Now, just like with addition and subtraction, I'm not going to take a lot of time doing examples of simple fractions. We're going to jump up to mixed numbers. Something like 5 1/3 times 2 3/4. Now, multiplying mixed numbers is actually an extremely difficult task. In fact, if you went to a university and found 10 math majors, I would say that out of 10 math majors, I'd be shocked if even one of them could show you the proper way to multiply mixed numbers. It's just a difficult process. But we're going to do it, but we're going to cheat. we're going to make it simpler by turning them both into improper fractions. So 5 times 3 is 15, plus 1 is 16 thirds, times 2 times 4 is 8, plus 3 is 11 fourths. Now, these are fractions in every way. I can cross cancel. 16 and 4 both divide by 4. 16 divided by 4 is 4. 4 divided by 4 is 1. Now I multiply. 4 times 11 is 44. And 3 times 1 is 3. And probably the most difficult part of doing it this way is we do have to break that back down into a mixed number. So 3 goes into 4 once. That's 3 with 1 left over. Bring down the 4. 3 goes into 14 4 times. 4 times 3 is 12. There's 2 left over. So that is 14 and 2 thirds. Now, just because I know at least one or two of you are curious, let's look at how we would do that with actual mixed numbers, the 5 and 1/3 and the 2 and 3/4. Don't write this down because I'm never going to make you do this. I'm not that cruel. You guys would have to really tick me off to get me to force you to do that. We're not going to go that far. You know, just like with whole numbers, if I have something like 32 times 43, I have to take this 3 times the 2, but I also have to do the 3 times the 3. Every digit of one number has to combine with every digit of the other number. Same is true when multiplying fractions and mixed numbers. This 3/4 has to multiply the 1/2, but it's also going to have to multiply the 5. So let's do that. 3/4 times the 1/2. 3 times 1 is 3. 4 times 2 is 8. 3/4 times 5. Well, to multiply a fraction by a whole number, we'll make the whole number into a fraction by just putting it over 1. 3 times 5 is 15. 4 times 1 is 4. That is 3 and 3/4. Now we move over to the 2. 2 times 1/2. Make that 2 over 1, so it's a fraction times 1/2. Well, that's 2 over 2. That's just 2. And then the 2 times 5. Just 10. To combine these, we have to find common denominators. Common denominator is going to be 8. So the 3/8 stays the same. 3 and 3/4 becomes 3 and 6/8. We got the 2 and the 10. 3/8 and 6/8 is 9/8, which is 1 and 1/8. So we'll keep the 1/8. Carry the 1. 1 and 3 is 4. Plus 2 is 6. Plus 10 is 16. Is that what I had? Something got off there. What did I do wrong? I did one of those wrong somewhere. I don't think it was that one. Maybe I did something wrong down here. Ah, yeah, this is 1, not 2 for 1. Huh? Still got a carried extra 1 somewhere there. So anyway, the moral of the story is this is not a happy process. Doing it out this way, there's just a lot of steps and a lot of room for mistake. So we are going to keep doing it like this, where we convert them into improper fractions. So let's do another example at least before we move on to division. Let's do 4 and 2/5 times 3 and 1/3. So we have to make those into improper fractions. 4 and 2/5. 4 times 5 is 20, plus 2 is 22/5. 3 and 1/3. 3 times 3 is 9, plus 1 is 10/3. And we are multiplying. We can, again, cross-cancel the 5 and the 10. Both divide by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. 22 times 2 is 44. 1 times 3 is 3. 44 divided by 3. Well, we just did this, so I'm not going to do all the steps out. That is 14 and 2/3. Get the same answer we had on the last one. Okay, well, let's look at division. We said that division follows the same rules as multiplication. And when we multiplied, we just multiplied straight across. Numerator times numerator, denominator times denominator. So does that mean that I can just do division? 12 divided by 4 is 3. And 20 divided by 5 is 4. Is that the correct answer?
No.
It actually is. Would that work every time? Actually, it would. So why don't we do it that way? That seems a lot simpler. Well, the reason we don't do it that way is because we run into problems that look like this. 3/4 divided by 2/3. If I were to divide that straight across, 3 divided by 2, well, that's just 1 1/2 or 1.5. And 4 divided by 3, that's 1 1/3 or 1.33333333. They don't divide out evenly. So when we see problems like that, what we've been taught to do is multiply by the reciprocal. Remember, the operation operates on the number that comes after it. So that division goes with the 2/3. When we change the division to multiplication, and the 2/3 gets changed to 3/2. That reciprocal, remember, is just flip the number over, exchange the numerator and denominator. And now it is multiplication in every way. We'll multiply. 3 times 3 is 9. 4 times 2 is 8. 9/8 or 1 1/8. Well, believe it or not, that multiplying by the reciprocal is a shortcut for what I just did up here. You might be wondering, well, how can it be a shortcut when this looks so much simpler? Well, because in this problem, 3/4 divided by 2/3, it isn't going to divide out evenly, so we have to rename this first fraction to make it divide out evenly. And the way we determine how to rename it is we use that second fraction. This fraction is completely reduced. There's no way we can reduce it further at 2/3. So I'm going to take the numerator of 2 times the denominator of 3 to get 6. I'm going to use that 6 to rename that first fraction. So I do 3/4 times 6/6. 3 times 6 is 18. 4 times 6 is 24. Now we've been over this before. 18/24 is exactly equivalent to 3/4. But now when I divide by 2/3, I can divide straight across. 18 divided by 2 is 9. 24 divided by 3 is 8. 9/8 or 1 1/8. Well, you might be wondering, well, how did they get from this to simply multiplying by the reciprocal? Again, it's not as big of a logical leap as you might think. At some point, somebody was looking at this problem with the multiplying by 6 in there, and they realized if we fudge our order of operations a little bit, if we do this division first, 6 divided by 2 is 3. 6 divided by 3 is 2. What we always get there is simply this fraction flipped over. So they just gave that the name reciprocal, and all that's left to do is to take the first fraction and multiply it. So multiplying by a reciprocal is just a shortcut of skipping all the steps of doing this longer process up here. It's a nice little shortcut because it makes it a lot easier, but that other process makes a lot more sense as to why it works. Okay, so let's step up to mixed numbers. Do 4 1/3 divided by 2 3/4. Now, it makes sense that if we're going to turn this into multiplication, we start out with the same step we did in multiplication, and that is turning these into mixed numbers. 4 times 3 is 12, plus 1 is 13, so that's 13 thirds. 2 times 4 is 8, plus 3 is 11, so that's 11 fourths. Now, this is still division at this point, so don't try to cross-cancel or anything like that. It's the next step now we're going to change it into multiplication. So the first fraction stays the same. Remember, division operates on the fraction that comes after it. So it becomes times. The 11 fourths is what we take the reciprocal of. We flip that over to make 4 11ths. Now this is multiplication. And if we could cross-cancel, this is not, if there was something that cross-canceled, this is where we could do it. In this case, there is not. 13 times 4 is 52. 3 times 11 is 33. We go to reduce that down. 33 goes into 52 once. We subtract, we've got 19 left over. So that is 1 and 19 33rds. Let's do one more example here before I give you homework. So let's look at something like 5 3/8 divided by 2 2/5. Let's find our, well, let's first turn these into improper fractions. 5 times 8 is 40, plus 3 is 43/8. 2 times 5 is 10, plus 2 is 12/5. Very tempting at this point to cross-cancel, but we cannot. This is still division at this point. Can't cross-cancel in division. It's our next step where we're going to change it to multiplication. So the 43/8 doesn't change. We're going to divide by the reciprocal, or sorry, multiply by the reciprocal. So instead of dividing by 12/5, we multiply by 5/12. Now here it is multiplication, but there is nothing that cross-cancels, so we'll multiply it out. 43 times 5 is 215. 8 times 12 is 96. 215 divided by 96 is kind of a pain, but we'll do it. Looks like it goes in there twice. 2 times 6, 12, carry the 1. 2 times 9, 18, 19. We subtract, there's 23 left over. So that is 2 and 23/96.
Are you able to simplify 215 and 96 before dividing it?
You could try, but there is nothing that divides into both of those.
Okay.
It looks like there should be. I'm really tempted looking at the 215 to think it divides by 3, but it does not. The only thing that divides into 215 is literally 5 and 43. Now, on your calculators, I'm not going to spend a lot of time today going over how to use your calculator, but many of you have a button that looks like this, ABC, or it might look a UND like that, or it might simply be an ND key, and above it is the UND. That is your fraction key. Some of you may even just have a square over a square like that. That is your fraction key on your calculator. Depending on your calculator, for the TI-30, the way that works, if you want to enter 5 1/2, the TI-30 has the ABC key. You use 5, then you press that ABC key. That tells the calculator that you're going to be entering a fraction, so you're moving to the next part. Enter the 1 for the numerator, then the ABC key again, and then the denominator is 2. That's the fraction entered like that. If you hit equals at that point, it'll display something like this, 5 1/2. If it's just a fraction, if you want to put in like 8/12, you just press 8, the ABC key, and then 12. And what it'll actually display would be something like this, 2/3. It'll automatically reduce it when you enter it. So over the next couple of days, take some time to play with that fraction key on your calculator and see how it goes. Okay, some homework for you. We do have a quiz coming up on Monday. I'll get that loaded in Blackboard here sometime later today or tomorrow. Your homework is going to be in the little book. Units 6, 7, 8, and 9. Again, the odd numbered problems. It won't be after today, after next week, there won't be too many times where I give you 4 units worth of homework. It does get smaller once we get into more difficult topics. For right now, I am expecting that many of you, like I said, are skipping over some of the easy problems at the beginning of each section because you already know how to do them. But make sure, like I said, you're doing the tougher ones at the end and the word problems and stuff like that.
And then where can we find those questions for people that don't have the small book, like in the big
Don't
one?
have the small book yet? In
No.
the big book, let me take a look. I believe it is chapter 2. Come on. So it'd be sections 2 to 8 through 2:16. The way the big book does it, it has one section with just calculations of fractions, and then the next section is word problems with them. So that's why there's so many sections out of the big book. Again, I'm okay if you just do the sections that are word problems. That's fine with me. Any other questions? Okay, since most of us are just working from home on the network today, I won't make you sit there at home and do homework with me watching. I'll let you guys out of here a couple minutes early today. You guys have a great weekend, and we hope to see you all on Monday.
Can I chime in quick?
Yeah, go ahead.
It's Colton Jacobson. I got here like 5 minutes late, but I'm on campus and I didn't see anyone else in the room. So I didn't realize that I could come in here. But I just wanted to let you know that I'm here.
Yep, they did. I was going to mention that they did inform me yesterday that they are going to keep the rooms open for me on campus on Thursdays, even though you are scheduled to log in on your own. That they will have the rooms open for me. That way they don't have an influx of students at the library signing up for computers there if they need it.
Okay.
All right, thanks. We'll see you all on Monday.